This is the lecture number 11 for the class 12th, and we're discussing the integration by partial fraction, and we have done up to question number 7 of the exercise 5th. Now I'm taking the question number 8, which is integration of x upon x minus 1 whole square x plus 2 with respect to x, and this is the partial fraction of second type, in which we have the whole square in one of the factor. So in that I have already told in the beginning of this exercise that you have to let a upon first factor without a square, b upon first factor with a square, whole square, and c upon third factor. As usual, add the right hand side, and the denominator will be cancelled out left hand side as well as the right hand side. In the numerator, in the right hand side, we have a into x minus 7 into x plus 2 plus b into x plus 2 plus c into x minus 1 ka whole square, and we'll find the value of a, b and c by using the second method, that by equating the coefficients of x square, x in the constant term on the left hand side and right hand side. So multiply and open the bracket, collect the terms containing x square, the x and the constant term, then equating the coefficient of on the both side. In the left hand side, the coefficient of x square is 0, in the right hand side is a plus c, so therefore a plus c will be equal to 0. The coefficient of x in right hand side is a plus b minus 2c, in the left hand side is equal to 1, and put it equal to 1, and the constant term in the right hand side is minus 2a plus 2b plus c, in the left hand side it is 0, so put it this equal to 0. You are now getting the three equations in three variables. You know how to solve these three equations by substitution method, and find the values of a, b, c by, or you can use any method. So I'm getting the value of a as 2 upon 9, b as 1 upon 3, and c as minus 2 upon 9. So put this value in the in this step number 1, and put the a as 2 upon 9, b as 1 upon 3, and c as minus 2 upon 9 here. These are the three integrals you have to do. This is simple. This is the integration will be log x minus 1 modulus. This is half 1 upon x minus 1 ka whole square. To take this to the numerator, that is x minus 1 ki power minus 2, and integrate by using x raised to power n integral, which is x minus 1 raised to power minus 2 plus 1 upon minus 2 plus 1, and minus 2 upon this log of x plus 2 modulus. So be careful with this integral. It is not log x minus 2 whole square. It is, take first of all this x minus 1 to the numerator. It will become x minus 1 ki power minus 2, and use the integral of x using the formula of integral of x raised to power n, which is x raised to power n plus 1 upon n plus 1. So this is the integration of this partial fraction, which is of the second type. In question number 9 of this exercise of exercise 7.5, question number 9 is 3x plus 5 upon x cube minus x square minus x plus 1. It is 3x square plus 5 in the numerator, and it is x cube minus x square minus x in the denominator. So first of all, factorize the denominator. You can take x square common in the first two term and minus 1 common in the last two term. Factorize, and you're getting x minus 1 into x square minus 1. In place of x square minus 1, if you put x plus 1 x minus 1, then it will become x minus 1 ka whole square, and this will become the partial fraction of second type, which we have just done as in case of question number 8. So what you have to let it here? You have to let it here a upon x minus 1 without a square, b upon x minus 1 with whole square, and c upon x plus 1. When we have the whole square in one of the factor, then you have to let a upon first factor without a square, b upon first factor with a square, and c upon this third factor. Now, as in question number 8, at the right hand side, the denominator will be cancelled out of the denominator, and open the bracket and collect the terms containing x square, the x, and the constant term. Now equating the coefficient on left hand side as well on the right hand side. The coefficient of x square in the right hand side is a plus c, and 0 in the left hand side, so it will be 0 is equal to a plus c. The coefficient of x in the right hand side is b minus 2c, in the left hand side is equal to 3. The constant term in the right hand side is minus a plus b plus c, in the left hand side is equal to 5. So equate them and solve these three equations by any method. The substitution method is the best. So find the value of ABC, which is I'm getting minus half plus 4 plus half. You put these values here, A, B, C, and integrate. See it here carefully. So it is minus half log x minus 1. It is again 4 integration of x minus 1 की power minus 2. It will be minus 2. So it will be minus 2 plus 1 upon minus 2 plus 1. Be careful with this integral. It is not log. I am telling you again as I have done in question number 8. And this is half log x plus 1. So the integration of this is a partial fraction of second type. Now question number 10 is very simple. It is a partial fraction of first type because in the denominator we have the factors of linear polynomial. So you let it equal to a upon x minus 1 plus b upon x plus 1 plus c upon 2x plus 3. Equate, add the right hand side, the denominator as usual will cancel out. You will get 2x minus 3 is equal to a into x plus 1 into 2x plus 3, b into x minus 1 into 2x plus 3, c into x minus 1 into x plus 1. In this you can use the first method to find the values of ABC. If you put x equal to 1, then put x is equal to minus 1, then put x equal to minus 3 upon 2, you will get the values of ABC as you have done in the previous question of this exercise. So I am getting x a is equal to minus 1 upon 10, b is equal to 5 upon 2, and c is equal to minus 24 upon 5. So put these values a, b, c and integrate. Say it very carefully. A, b and c. I put it here. Integral, it is log of mod x minus 1. It is a log of mod x plus 1. It is a log of 2x plus 3 upon minus 2. See it very carefully because it is 2x plus 3 and its derivative is plus 2. So you have to divide it by the derivative of 2x plus 3, which is 2 here. So it is log 2x plus 3 divided by 2 and arrange it. You'll get the integral of this function, which is partial fraction of first type. Now question number 11, see it carefully. It is 5x upon x plus 1 upon, this is x plus 1 into x square minus 4. Now you can factorize this x square minus 4, which will be x plus 2x minus 2, and it will become the partial fraction of first type as we have just discussed in question number 9. So you let it equal to a upon x plus 1, b upon x minus 2, c upon x plus 2, and added right hand side, denominator will be cancelled out. If you put x equal to minus 1, x equal to 2 and x equal to minus 2, you will get the values of ABC as usual. Put the values of this ABC here and integrate. Now question number 12, again it is improper fraction, as we have done one of the question in the beginning of this exercise. Why it is a improper fraction? Because the degree of the numerator is more than the degree of the denominator. So you have to convert into quotient plus remainder into upon divisor, which is the proper fraction. So divide numerator by denominator, you are getting as quotient as x and remainder as 2x plus 1. You know how to divide like this. So quotient plus remainder upon divisor, it is a proper fraction. You separate this integral, the integration of x you can easily do. It is x square upon 2, and see it very carefully, it is 2x plus 1. Now this is a linear upon quadratic. You try to make the derivative of the denominator in the numerator, which is already there. So you break into such integral such that in the 2x upon x square minus 1 you separate it, because 2x is the derivative of x square minus 1 and 1 upon x square minus 1. Now this is a special integral of 1 upon x square minus a square. This is integral, you directly do it, and this is if you let x square minus 1 is equal to t, x square minus 1 is equal to t, then this 2x will be cancelled out. You will get 1 upon t, and it is log t. This is 1 upon 2a plus log x minus a upon x plus a. Special integral, replace the value of t. Okay, now you can use the properties of log to simplify this fraction. Otherwise you can leave it here. You can leave it here also. So this is the question number 12, and this is the function which is improper because the degree of the numerator is more than the denominator. Now question number 10 is of third type partial fraction, in which we have one of the factor as a quadratic polynomial which cannot be factorized. So you have to let it like the partial fraction of first type, which is a upon x minus 1 minus x plus bx plus c upon 1 plus x square. So this is the third type partial fraction. Whenever we have a quadratic polynomial which cannot be factorized, so in the numerator of it you have to put a linear polynomial which is bx plus c. You can light it here this else also, that is ax plus b upon this I have already told you, x square plus 1 plus c upon 1 minus s. You can break it like this also. So as usual, at the right hand side, denominator will be cancelled out, multiply and open the bracket and find the values of ABC by using the second method, that is equating the coefficients. Multiply and open the bracket, collect the terms containing x square, which is x square a minus b, containing the term x, that is b minus c, containing only the constant terms, and equate the coefficients of like terms. A minus b will be equal to 0 because the coefficient of x square in the left hand side is 0. B minus c is also equal to 0 because the coefficient of x in the left hand side is 0. The constant is a plus c, in the left hand side it is equal to 2. So a plus c is equal to 2. And solve it. You will get the values of ABC by using the substitution method. Put the values of ABC, a here, b and c, a, b and c. Now this integral you can do it easily. It is log, see it very carefully, log 1 minus x divided by the derivative of 1 minus x, which is minus 1. See it very carefully, minus sign is there. And it is bx plus c, it is 1 plus 1x upon x square plus 1, and you break into two integral, that is 1 upon 1 plus x square, which is an integral of tan inverse x, and this is x upon x square plus 1, which is a linear upon quadratic type question. Here we have to bring the derivative of the denominator in the numerator, which is 2x, so multiply and divide by 2, it is 2x upon x square plus 1. If you let x square plus 1 is equal to t, it will become 1 upon t, which is the integral of log x t, and replace the value of t. So this is the partial fraction of third type. Now in question number 14, it is a partial fraction of second type, which is containing whole square. So you know how to let it, a upon x plus 1 without a square and b upon x plus 2 whole square. When we have the whole square, a upon factor without a square, b upon factor with a square. At the right hand side, denominator will be cancelled out. Again, find the value of ABC by using second method, by equating the coefficient, collect the term containing x, collect the constant term, the coefficient of x, a in the right hand side, and the coefficient of x is 3 in the left hand side. So a will be equal to 3 and 2a plus b equal to minus 1, because 2a plus b is the constant term and minus 1 is also the constant term. So simplify this equation, you'll get the value of a and b, put it here, and it is simple, 3 log x plus 2 in the mod, and it is whole square, so minus 7 x plus 2 bring into the numerator of minus 2 power, so x plus 2 raised to power minus 2 plus 1 upon minus 2 plus 1 plus c. So this is the questions up to question number 14 of the integration by partial fraction. We'll discuss in the next lecture. Thank you.